So I want to look at something called the residuals. And this is going to be a lead in to gradient boosting. So this is a little plot that you see up here. And all it's doing is measuring the residuals. The residuals are simply the distance from, say, the actual value, which would be the dots here, to the model, which would be the line. Now, what's really important about this for gradient boosting is that residuals can be positive or negative, right? Because if it's above the line, then I think you'd have a positive difference, below negative. It could be vice versa. It doesn't really matter um, in the sense that they're going to be used to balance each other out. So gradient boosting is a different kind of ensemble method. And instead of training kind of on, say, like the whole data each time, it trains on the residuals. And I think the best way to understand this a little bit is to actually try to do it from scratch. Okay. So I don't usually do this, but it'd be kind of fun, which is writing code from scratch. All right. So how are we going to do that? Well, let us go into the, I'm going to go back to get a different data set here because residuals, I think the idea is best explained. I would still use, we're in chapter 4 now, by the way, but we can still use this bike rentals cleaned. Okay. So go to that. That's in chapter 3. It's probably in chapter 4 too. And we're going to copy this raw code and come down here. Okay, so new text header, gradient boosting from scratch. So there's a new idea here. You could do a new notebook with this, if you want. And how are we going to do it? Well, let's just quickly load in this new data. All right, bike rentals cleaned, import pandas as PD, df equals pd.read underscore csv. Just quickly look at it. I've been quickly looking at it a lot. I will go ahead and do it because I just want you to always do it, even though it's been checked, right? But you want to be sure. Right now, note that I'm rewriting the code from above. Okay, so I'm not preserving it. I'm not going to change the labels because I'm just going to move on and just focus on this data set from here on out. Right, and so recall what we're trying to predict is in fact the last column, the count, the number of bike rentals. And so what we can do then is set up x equals df.iloc, all rows, all columns except for the last, and y equals df.iloc, all rows, and the last column. Okay, so that's all standard. Set up our x and y. Now, first thing I want to do is build a decision tree regressor, but we're going to go ahead and split the data now, okay? Now, we haven't been splitting the data, and here we're just going to do it for emphasis. We'll focus a little bit later on the proper techniques of like splitting data versus using cross-validation and all that. All right, so from, let's see, sklearn.model selection, going to import train test split. And then we're going to use a decision tree regressor. So like how random forest is built on decision trees, gradient boosting is also built on decision trees, right? So regressor, because the count here could be any number, it could be above or below, kind of like that line I showed you in this visual here. Okay. All right, so from sklearn.tree, import decision tree regressor. All right. And we're going to now, well, before we build, we need to split the data. Okay. I don't know. I'll just leave those there. Okay, now I split the data. Really, like, it's good to put the comments always, but I don't want to waste time with that for you all. I'm just trying to get the code out at a pace that I think will work, honestly. All right, so imports. Okay, split data. And so here's how this works. You say it's always xtrain X test, Y train, Y test. And we're going to set that equal to train test split. And we just split X and Y. Okay. And now what we're going to do is we're going to build a decision tree, right? So to start with gradient boosting, okay, and again, I haven't gotten into what is gradient boosting. Gradient boosting is going to be a sequence of decision trees, but each time we do a new decision tree, we're not going to fit it on the target column, okay? The first one we are, right? So the first one, we're going to get as close as we can to these predictions, okay, using one decision tree. And then the second, like imagine the first one then is like you get 980, right? So you're 5 off, right? Great prediction. The second round, what we're going to do is fit it on the residuals. So the residual is going to be 5, right? And so the new target column will be 5. Okay, we'll see how this works with code. And we'll talk a little bit more hopefully about why it works. Well, okay, so first we just need build decision tree, okay? Build first decision tree. Now this is called a base learner in gradient boosting, okay? Because it's the beginning, it's the base tree. And I want to explain this, okay? The base model is supposed to be like not that great. It's not supposed to fit the data well, okay? It's not, it doesn't have to be terrible or anything, but the idea behind gradient boosting is to turn a weak learner into a strong learner because you're training on errors. You're not trying to get it right the first time. You're trying to get it right after a bunch of times, okay? So how are we going to do that? Well, we could do just one simple thing. Call this tree 1, okay? And what's it equal to? Well, it's the decision tree regressor. And let's just set max depth equal to 2. Now, this is standard for a gradient boosting base learner, okay? Like it's right, if there's only 2, like the max depth is only 2, then you're only building like, your predictions aren't going to be that good, right? Because you will only have one tree. But for gradient boosting, that's interesting to start with. Okay, and then we're going to go ahead and fit it to data. Okay, fit tree to data, right? This is now when we're fitting it to the data, right? Do you know what to fit it on here? Right, we split the data here. So we're training, so we do it on the training. So X train and Y train. Okay. And let's just go ahead and run that. You can see I get a decision tree regressor, max depth of 2. Okay, so like, what do we do with this? How do we do something? Well, note that we want to actually look at the predictions. Okay, right? We need to know what the predictions are. So we're going to store those. So Y train predictions. Okay, so making the predictions from Y train. It's because, well, you'll see why I'll call it that later. And then, so we're using tree1 dot predict, okay? This is all this code does is it tells us, and the predictions are from, by the way, the X train. Yeah, X train. All this does is it gives us the predictions of the tree, right? Like here, you fit it to the data, but we want to store the predictions, right? I said, hell, maybe you got 980, it was 5 off. We want to store the 980, right? Okay. So access predictions from first tree. You could say store. Store predictions from first tree as Y train pred. And now, what are we going to do? Let's run that. What we're going to do is compute the residuals. Okay? So here goes. What are the residuals? Go back up to this image. Okay, so here, let's just look at this first one. The model predicts, say, I don't know what that is, 14, right? And the correct output is maybe 17, so it's off by 3. So you just have to subtract, that's all. So to get the residuals, I'm going to call these residuals y2 train, okay? And then what that's going to be is, it's whatever y train is. Train is because we're not using a test set here. Right, so what it actually is, minus then what the model says. And so the model here says, that's what we just did. It's y train pred. Okay. Right, it's just computing the difference between the two. Okay, so what do you do with that then? The whole idea is this. That's what you use to do the second round of decision trees. Okay, so what you're going to do is build second decision tree on residuals. Right? Let's look at how this works. So I just call it tree2 equals decision tree regressor. Okay. Now, what's what here? Look, wait, the decision tree regressor. Sorry, this should be the same, which for us just says max depth equals 2. Okay. Now, importantly, we fit it. Okay, and this is the key. This is the key right here. You ready? It's not like profound code. It's just the idea is, this is the key idea behind gradient boosting. Okay. So, well, I wrote, this is actually what's coming. It's right here. So tree2.fit, right? You're fitting it on, see, the X train is the same, right? Because your input's always the same. But the output is no longer Y train. We already did that. It's the residuals. It's Y2 train. So that's why I called it Y2 train, because it's going to be the training data for the second tree. Okay. See, you still have a decision tree regressor, but now this fits it on the residuals. Okay. I know this can be, what I'm going to do is I'll do like one more, and then I'll go back and look at the code one more time. And the idea here is just to get the general idea, because we're going to use this gradient boosting sklearn model to do it like quickly. So then we just repeat process, really. Repeat process of training on residuals and building new trees. All right, so where did that start? It started with, we had to get the predictions, right? So to get the predictions, we've got to do y2 train wait. This is the problem. I'm looking back at other code. Let me look at the code in front of us. Okay, where did I get the predictions? I got the predictions right here, right? So we want to do a tree2 prediction now, and we're going to call it y2 train prediction, right? And we get this from tree2 dot predict, and then it should be x train still, right? Because the input is still just like the x train, but the point is we're making the prediction from the second tree, which is fit on the residuals. Okay. So after we get the predictions, we need to compute the residuals. I'll add in, I think that the steps here, I think they're important. So 1, get new predictions. 2, compute new residuals. And so basically that we would call this y3 train, right? Because it's going to go into the next tree. And it's going to equal, well, it's just the difference between, what is the difference between? It's the difference between y2 train, the actual residuals, and the predictions. I believe that's right. The right train. Yeah. Okay, so And then you could say 3, build new tree now, and it's on the residuals, right? So it's tree 3 equals decision tree regressor. Keep the max depth. I'm actually going to do, well, I'll come back and do it. And then, well, to build a new tree, we really fit it too. So tree3.fit. Now, importantly, right, we fit it on X train and then Y3 train. That's the advantage of this weird labeling system. You know what to put in. Okay, let's run that. Good. I do want to change, well, okay, so we've done this process now, but what we haven't done is actually scored a model. Okay. So how do we do that? Well, let's do that now. Okay, so what we're gonna do is score a model. Well, what we have are 3 rounds of predictions, okay? So we've got, say, the Y1 predictions could be tree 1. Now we're scoring, right? So what are we gonna use? Dot predict on X test, okay? So what we're doing here is we're generating a prediction basically from the test set, okay? But now you want to do it for each one. So Y2 prediction equals tree2 dot predict X test, and Y3 predictions equals tree3 dot predict X test. Now, if you're getting a little bit lost, just note it's really okay, because all I'm actually using this code for is to try to help you get the general idea of how gradient boosting actually works. We're going to shortcut all this really quickly soon. So I've got these 3 predictions, and you know how you combine them? You actually just add them all up. So you say Y predict then is Y1 pred plus Y2 pred, all the predictions plus Y3 pred. Okay, those are the predictions. Now, you may wonder, like, well, how is this possibly better than one prediction? Because you're just like adding more. But it's because the positive and negative thing. So it actually should converge closer to 0. And that's a big idea. All right, so what do we do now? From sklearn dot metrics, import the mean squared error. There it is. Let's even call it as MSE for mean squared error. And now what we're going to do is we're going to take the MSE of Y test and the Y predictions. Okay, so we're comparing now the 2, right? This is the first time we've used Y test here. Okay, I'm going to go back through the code, but it's the first time we've used Y test, and we're going to get the mean squared error, but let's actually get the root mean squared error. That's what we usually get, so to the 0.5 power. So that's just the RMSE, okay? That tells us how good the model is, right? So let's see how we did. MSE not defined. I thought I said as MSE. I tried to. So as mean squared error, I meant as MSE, it changed it. $904, not bad actually. Okay. Let's go back through the code. So because this is building a gradient booster from scratch. Okay, this is, well, there's the data. There's the splitting into training and test set. That's standard. I want to do one more thing, and you'll see why later. I want to set the random state so that we can get matches here. We're going to put random state equals 2. Okay, look, this has been done many times. You just like build a decision tree, like done. Like we've done that. Okay, and we haven't done the style as much because we've been using cross-validation, but this is also very standard. So like you just like say, okay, if you're going to score the model, you want to know what its predictions are, okay? So you use its predictions, and you would typically like, let me just, I don't want to like clutter the code, but maybe I can show you what it would normally do. You would just run the scoring metric on the predict y pred versus y test, okay? But in this case, knowing in advance that we're going to use this to compute the residuals, we don't score it yet, okay? We say no, these predictions, right? These predictions, which are basically the line here, okay? That's the prediction. It's the line. We're going to use the differences to build new trees. That's the key, okay? So back to the code. Now when I get the predictions, I use those to compute the residuals. You just subtract. It's actually, it's pretty simple arithmetically in that sense. You just subtract, okay? What do we subtract? We subtract the actual values of the training set from the predictions. Cool, okay? But what do you do with that? That's the key, is you build now a new decision tree. Okay, same defaults. We're going to add in that random state equals 2. And you fit it to the what? This is the whole point. Same x, same input, all good. But look, this is the residuals. So you're training now on not like big values like 900 and 800, but the differences like 100, maybe 73, right? 11. Some of them could be big, like 390. And so you're fitting them on a smaller data set. Okay, fine. What then? What's then is that you repeat this process. And it starts with, you get the new prediction. So now we're on tree 2, right? And, same input. But again, because like we're trying to get smaller out, we're training on the residuals, this is going to be now smaller, okay? But now we're at a second round, so we get the residuals of the residuals, right? Because, see, the first time you get this, the second time you're going to have much smaller, like everything gets smaller, okay? It gets closer to the line, right? And you just repeat the process, new residuals, new decision tree, and fit it on the new data. Okay, now we stopped at 3. Okay, normally you keep going, right? But the point is we need to move on. And there's a shortcut to doing this, which I'll show you soon. But to score the model, then you say, okay, I built 3 trees. I trained 2 and 3 on the residuals. 2 is on the residuals, 3 is on the residuals of the residuals, right? So it's narrowing down. I sum the predictions, okay? And I score on those. I score on the sum of the predictions, right? And the reason why this works well is because some of these are too high, some are too low. And so this is going to bring them closer to the line. This is going to bring them even closer. That's the idea. Okay. And because positive negatives, when you sum them, and then you just score it. Now, when I did put in I did not here. I want to do the random state equals 2 again. And I will show you why the subsequent clip here. But I'll just go to the top when we first did it. Now they have the random states done. And if you go to a coding cell, you can always do runtime, run after. So I want you to put in the random states and to run this code. And then we'll see how gradient boosting from sklearn can make our lives much easier.